All right, so I worked on this project for ARM64 assembly. Um, I'm definitely not in any way an expert with assembly. I'm a beginner, but I thought I'd make this video anyway because it sort of makes the project more fun when you can show it off at the end. And I also think it might be helpful to a beginner because a lot of times the more advanced tutorials and advanced helps skip many steps that are not known to a beginner. So I just had those kind of beat into my head here through this project, so I can share some of those. And then also, I'm not an expert, and this was not intended to be polished code anyway. I can see things that I can improve. Um, but if you see anything that could be improved, that's maybe not good practice or whatever, feel free to point it out. I don't mind learning. And also keep in mind that this is not code that should necessarily be copied. It's more for explanatory purposes. And as a beginner, I benefited pretty heavily from some resources. So there's a YouTube channel, Callous Coder. His videos on ARM64 were extremely helpful. But also, the way I started on this project, there's an emulator online that's actually using ARM32. And I can't remember the name of it right now, but I used it many months ago, 6 months to a year ago, and I really enjoyed it. And because of that, I got this book, Assembly Language Using the Raspberry Pi, a Hardware Software Bridge by Robert Dunn. And the book is excellent. And I started reading that book, and that's what made me want to buy the Raspberry Pi and actually do it on the Raspberry Pi instead of on the emulator. Um, So the difference though, I didn't know when I bought my Raspberry Pi that there's ARM32 and ARM64. So the book and a lot of the other helps cover ARM32, the older architecture, whereas my Raspberry Pi is ARM64. So that was a real learning curve there. But yeah, anyway, so let me just show my project. Let me kind of start from the beginning here. So I just have it connected over my network. This is just remote desktop. It looks funny because my computer's in Russian. It's just local IP. And then my super secure username, password. And then let's close this, pretend I didn't already have it open. Pretend this isn't my second recording. And so there's kind of a weird thing here, and I found this through an online um, forum, so other people have a problem as well. I like VS Code, but you can't just open it. I don't know what the deal is, if it's because uh, I think if I were connected through my monitor to my Raspberry Pi that I could just open it, but because I'm going through RDP, for some reason you can't just open it. I have to disable the GPU. And let me make this bigger so it's actually readable. Bam. All right, so we want code disable GPU, and then that way it will display properly. It doesn't display if you don't do that. I've already got my program open. So this is my code. I'm going to speedball through some of this, but all it actually does, so when I run it in the terminal, it's going to ask for the user to enter some input. The user will enter some input. It stores that in a memory location that kind of my variables. Not really sure if that's the proper term, but I'm going to call them variables. So the initial variable for the user input is called input. It's just 20 bytes that are initialized with zeros. And then after that, it's going to take the user input and it's just going to copy that into a new memory location called copied. That sounds kind of silly. I actually just did that for debugging purposes when I was trying to get the main core of the project to work. And but you'll notice, so there's a lot of different kinds of bugs and things in this program, or just things that could be improved. One of them is that the copied function, so I can store 20 bytes. This copied function is only going to get the first 8 bytes. Um, so yeah, so it doesn't grab more than that. at this point, and I'm not really interested in having it grab more than that because at that point I don't think I'm going to learn a lot from doing that extra step. Then after that, it takes it and it flips the order and stores them in this new location called flipped, which that also only grabs the first 8 bytes. So it takes, of the 20 bytes, it takes the first 8 bytes and it flips those first 8 bytes and prints them out in reverse order. And the rest of them just get chopped off. So that's how the program works. Um, let's see, some different bugs that I'm aware of, or not, or bugs or room for improvement in my program are, I say string all over the place, but I'm pretty sure none of these are strings because I did not use ASCII Z to add the 0 character at the end. Um, so I don't think they're actually strings. I'm pretty sure they're not officially strings, but I call them strings. So, and the other thing, I have a number of places where there's hard-coded text, so that is these, again, not officially strings right here. So initially it's going to pop up and ask the user to enter a string. Then after they enter the string, it's going to print out, it's going to say the text you entered is, and then print from the memory location. That's going to say, you know, like, hey, this is the copy. It's going to say, oh, okay, this is the text flipped, and then it's going to print a bunch of spaces so it looks better, or a bunch of return keys so it looks better. Something else interesting maybe about the program. I'm not going to go through this line by line because it's really long. Just another room for improvement. So the longest part of this by far is the section where I flip it. And this is just a repeated pattern over and over and over again for every letter. I'm sure I could have made that into a loop. I didn't do it. And the point of this is pedagogical, so I'm not actually going to gain any new information by turning it into a loop. I can easily see that it would be better as a loop. But the main stuff I wanted to learn is already there as is. So, all right, so I think that's enough on that. Let's dive into the program. Try not to get any of this covered with my camera. So that should be good like that, I think. All right, so let's see, first of all, where are we in the Raspberry Pi? And I just happen to know that I stored it in a folder on my desktop. So we're going to change directory to desktop. Check it out again, list. It's in that folder called assembly code. So change directory. This time I need the, what do you call those things? Single quote, because there's a space in the name. List again. So here you'll see that I already have what I want to call it is RFW. What did I make that stand for? I forget what the R stands for. Flip right. Read flip right. That's what I had it stand for. So I'm going to pretend that the object file and the executable file don't exist and just show how those are compiled. And so let's pretend that all I have is rfw.s. So first thing we'll do is assemble. We're going to need to add a -g because I want to use the debugger, and that sets it up for the debugger. And then -o rfw.o, we're gonna, so the output name is going to be rfw.o, and that's what I'm naming the object file that gets outputted. And then the file that we're using is rfw.s. So we have some warnings, but we don't have any faults. That's fine. And we now, it was already here before, but if it wasn't, I now created a rfw.o, an object file. Now we have to link it, ld rf, oops, -g, -o, rfw. That's what I want to call the executable. And we're using rfw.o, the object file. So now if it hadn't already been there, I just created RFW And even with it being there, I just wrote over it, so I created a new one. And so then another little thing about assembly. So I am doing assembly through Linux. It would look very different if you were going through Windows. It would look very different if you were going just straight up embedded, just dealing directly with the hardware. And also it would look different depending on which type you're using. As I sort of mentioned this a little bit, I'm using ARM64. ARM32 is very similar to ARM64, but there are some important differences that are really confusing if you're brand new. But once you get them, they're not so different. But then if you go to an Intel version like 8086, then it's very different as far as how the code is written. Um, and so then the difference here as far as like if I were just writing straight to the hardware, I would use a lot of like hardware addresses and I would say, hey, point to this hardware address and do such and such inside this hardware address. But because I'm working within the Linux operating system, Linux does not allow me to interact directly with the hardware. Instead, I have to ask Linux to interact with the hardware on my behalf. So the coding will look very different depending on which one of those things you're doing. And so for the type of program that I am writing, basically it's just going to be a series of here's what I want to do. Let me go ask Linux to do it. Okay, now here's the next step I want to do. Let me go ask Linux to do it. And so we're doing all these system calls is what's going on. So let me first just demonstrate the program. And my file name again is just RFW, but I'm also not an expert on Linux. For some reason I can't write RFW. It won't run that way. I have to do this / thing, RFW, to get it to run. And the code I have been testing with is A through P. Let me just go ahead and try something like, I don't know. How about something real dumb like that? So this is a program. So um, here is what I entered. This is a program. This it spit out originally, so it's pulling this from the memory location for like the variable input. Then it says there's a copy stored in a different location, and it's again, it doesn't grab all of it. It just grabs the first 8 characters, and then from a different memory location, it flips those 8 characters and prints them out in reverse. So that's what's happening. Let me actually debug and step through that just a little bit here. So to use the debugger, we go gbd ./thing rfw. Did I get, it's gdb, isn't it? gdb ./rfw. There we go. And then the first thing we have to do is set our breakpoint. I'm going to set my breakpoint at the flip label. So that's going to be down here because the stuff that I'm going to want to show is a little bit after that. So we'll start there. Then we have to run it with R. So now it's running, so I can just single step by pressing S. And then it's a little bit awkward the way it does this. I don't really know why, but so there it says, let's get a couple steps here. So here it says we're loading the address, the address where the input data starts. So this is just the address. We're loading the address into X1. Then this one, where it has an address from another register, and it has the brackets around it, that is talking about the data in the data that's pointed to. So here we're loading the data that's from the input, which was the user input. I skipped over that part of this program just now, but that's where the user input was stored. So this is taking the actual user input and storing it into X5. And that's the reason that the last half of it gets cut off because you can't hold all 20 characters in X5, and I don't feel like adding the rest of the characters. But that's where the chopping off happens. So here we're storing the actual data from the characters in X5. So that should be, oh, I entered S. Hold on, let's quit this and restart this. I want to enter the A through P for quit, yes. So let's run it again. Breakpoint, flip, run. So now enter a string. I misread that last time. I thought it was already in. I didn't realize it was waiting for the string. So we're going to go with A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. That's 20 characters. Now let's step the program. All right, so we're back where we were. Um, so now we have a lot more characters. So all those characters then, well, the first 8 of them, which would be A through H, are being stored in X5. And from here, then I start this process where I flip the characters around. So inside the registers. So let me pull up the registers at this point and show what's going on. So we want inspect register. First, actually, let's look at the data. So we have X, we want 20 characters. I just set them all up to be 20 characters. We're actually only looking at 8 characters, but we'll just keep it at 20. C for character, the first place is input. And you'll see there we have A all the way down to P. So A through P. I wonder now if I actually have 20 characters because it looks like I still have some zeros. Maybe I miscounted. Anyway, we have A through P stored there. My next variable that I have is copied, where I just copied, but again, the way I did the copy, it's going to chop off everything after the first 8. So you'll see that A through H is copied. The last ones are cut off. The memory address pointer is different. So in hex, this is 410378, and the start of copied is 4103A0. And then if I look at flipped, that's what we're working on now, so it should be empty. And it is, they're all zeros, which is what I had them initialized to. So now let's step one more time and let's set up some registers. So I, R, and then when I look at my program here, here's where I start the flipping and just, because I wrote the program. X5 is going to have our original data, and then I never edit that. And then what we're going to do is X6 all the way to X, I think it's like 13, is where the letters will end up getting stored. Each letter in its position will be stored there. And then at the end, I'm going to sum all those letters up to get to X14. So basically what I'm trying to get at is I want to monitor X5 through X14. And I don't really want to inspect all of them because it's it's hard to look at. It's too much. And I actually think you can just use a dash here, but I haven't tested that yet, so I'm not going to do it. This is the way I was doing it before it works, so that's how I'm going to do it. X13, X14. Okay, so there's all my registers. Again, X5 has the original characters, but what's really interesting, so let's go to right here at copied, because this is actually the same character set. It's just A through H. And unfortunately, these are decimal, and this is hex. So don't let that confuse you. But we're going A to H. Now, when I pull up the ASCII character set, oops, we have lowercase a. This is lowercase a, and in hexadecimal, it is 61. and then H is 68. So we're going 61, 2, 3, 4, 5, 6, 7, 8. We're going 61 to 68 is A through H. So this right here should be 61 to 68. So 61, 62, 63, 64, 65, so on to 68. That's currently the order that it's printing out. And the reason I'm hammering on that so much is you'll notice in the register, it's actually stored backwards. So the register is storing it from right to left. Here's 61 all the way to 68, but the memory is storing it the opposite way. And when I print it, it's printing it out in the order that it appears in memory. So we still want to flip these. So the goal then is to have this go 61 down to 68. 61, 62, 63, 64, and so on to 68. That's the goal. And then when it copies that into the register, into the memory locations, the memory should go H, G, I can't do this backwards, maybe F is next. And that actually represents 68 down to 61. So that's the goal. Something worth pointing out that I didn't point out, this OX at the front means that this is viewed in hex. So this is the same number in decimal. For characters, it's not very helpful to look at it in decimal because in hex it's really convenient because every two digits will represent a character. So you can easily distinguish the characters. This is one character, this is the next character, this is the next character, and then you could just go to the ASCII table like we just did. In decimal, you just doesn't work that way. There's not an easy way to distinguish where the characters start and stop here in this big number. So yeah, so let me step a few times and show what this is actually doing. So step, 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 step. Let's actually step a whole bunch of times. This is 9, 10, 11, 12. All right, let's look at the registers again. I'm pressing the up arrow here. Come on, there it goes. All right, so here's our registers. I stepped through the process quite a bit. I'm all the way down to like here. This is the last step that was done. This is the next step that's going to be done. And this is a little bit confusing, I think, but the values that we're looking at are actually reflecting this step here. So the step that's last printed is not yet reflected in these values. That's what will be reflected in the values next time after I hit step again. So the last step that was done to get what we see down here was this step, this rotate right. And so let me kind of show what's going on here. And this is X12. So you'll see right here, X12. This is setting X12. So let's get at this first one for X12, which is right here. So X12 is built off of X5 initially, which is the full set of characters. And what I do is I take that full set of characters, and I'm going to do an action to it, rotate right, and then I'm going to copy the result into X12, and this number 16 tells us how far to rotate it right. These numbers here for all these are shifts and rotates is what I'm using. If I keep them in multiples of 8, that represents a character. So like one character would be 8, two characters is 16, three characters is 24, and so on. So what this rotate right is doing is going to shift, and the difference between rotate and shift, so these ones here that start LS are shifts. They pad zeros and they cut letters off. The rotate doesn't cut anything off, it glues it to the other side. So I didn't actually print this out step by step in that sense. Well, I would have, except I went past it because I've already done the other steps. So I keep changing the data in X12. So I've manipulated X12 several times based on what you're seeing down here. But initially we rotate, so it would take this data here, but it would shift it, should be, I got my rights and my lefts mixed up. It's going to shift it so that the two characters, so 61 and 62, so that 62 ends up down here. So this would say 62. How does that go? 62, it should be, would be 61. Yeah, this would be 62, this would be 61, this would be 68, this would be 67. So it just shifts it that way. That's the first step that I did. That's this rotate. The next step is this shift right by 56. And when I shift right by 56, that is going to, that's 7 characters, right? 56 divided by 8 is 7. That's going to cut off the 7 characters over here because we are, let me get something to write with. Let's try, just want to open a new text file. All right, this has all kinds of stuff on it because it's not new, but let's go new. Okay, so, and this is also really small and hard to read, but so we started with 68, 67, 66, 65, 64, 63, 62, 61. That's what we started with. The first step, the rotate, puts us at 61, 62, 63, 64, 65, 66, 67, 68. That's what rotate does. It shifts it around like that. Oh, no, sorry, 62. It's supposed to be 62 and then 61. That's what rotate does, right? No, what did I do here? Hold on a second. It was supposed to be 62, 61, 68, 66, 67, 66, 65, 64, 63, 62. No, those two aren't there because they're on the other side. Okay, that's what it's supposed to be. So that's from the rotate, that's what it does. Then when I do this next step right here, shift to the right by 7 characters, it's gonna smash everything to the right. And when it does that, it fills in zeros, which is why this is kind of annoying that it's not showing the zeros down here, but there's padded zeros down here. So we would have 1 character, 2, 3, 4, 5, 6, 7, 62. That's what we're left with, and I cut off all these other characters. Then we're going to shift in the other direction, and that is to now I need to put this in the correct spot. So 62, we're almost to the end. This is the, so it should go like 61 was the first letter, that's A. So this is B. So B should be in the, it should end up in the like the second position. It's flipped, you know. So currently the order I'm trying to get them to go in is actually A through, what is it, H, right? A, B, C, D, E, F, G, H. We're trying to get it to go A through H because then when it prints it, it actually does the opposite. So I want B to be in the second position. So there's already zeros on the left-hand side, and I want 62 right here. So to do that, I can just fill in 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm missing something in my brain about how that's working so that it's 7 instead of 6. But anyway, for whatever reason, I'd have to think about it more. It ended up being 56, and when I shift it by 56, it's going to fill in the zeros here. And now that is in the correct position that I want it. I'm also actually still missing something. No, I'm not. I'm sorry. I did flip it 7. So actually, and this was actually a mistake in my algorithm. This is completely unnecessary. I could have shifted it like I just said, I'm fairly certain that would have worked. But for some reason, I shift it all the way back to the first position. And that's actually because it's what I did on the first character, and I just copied it for all the other characters, but it's completely unnecessary for all the other characters. But it's what I did. So it is actually moving it to the first position, but that's not the correct position. So then I rotate to bring it back around to the correct position. So that's this last step. So that rotate will then move it so that it is 0, 0, 6, 2, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So that's what happened. So that's like the algorithm for a character. And then if I step out of this for a second, so the algorithm for the whole thing, what I have is you can sort of see it here, but it doesn't pad the zeros on the left, so it's not super obvious. And I like to be pedantic, so I'm going to be. So the first one, 68, that is actually all the way on the right. So what that really says is 1, 2, 3, 4, 5, 6, 7, 68. And then the next one, it has 2 zeros on the right. So that's 1, 2, 3, 4, 5, 6, 67, 0, 0. The next one has 4 zeros on the right. And after that, I'll stop writing because I think at this point it's very apparent what's going on. 66. So now all I have to do at the end is just sum these, and you can see that 68, 67, 66, they're just going to drop down in order. So at this point in the step where I don't have the rest of them filled in yet, it would be 66, 67, 68. And if we change those to characters, I'm just going to still call these zeros. So this was A, B, C, D, E, F, G, H. So F, G, H. Those are the characters that we have. And the goal was to get it A through H because when we print it, it's going to print in reverse order. So at this step right here, which is not the same step on the left here, I just didn't want to keep typing longer, but if I were to print this out, I would actually get H, G, F because it prints them in the reverse order. So that's what's going on. That's how the algorithm works. That's how the debugger works. That's stepping through it. In the program, we were at setting X13, and X14 is what I used to add them all together. And again, this could also be improved greatly. I just chose to keep. So the first one I did add 2 registers. So X6 through X13 is the letters. And so here I'm adding one of the letters with one of the other letters, or concatenating would really be what's going on actually. And after that though, I just add 1 to the total. So this would be one of the letters added or concatenated with the total that I have currently and then stored in the new total. So it ends up making this a lot of steps because I kept redoing the, I could have cut this in half is what I'm trying to say. So now after that is going to be the step where I load the pointer that points to the flipped variable. But if I view the registers, it's actually going to show the output here, which should show 61 to 68 inside of X14 because I finished the adding process. So let's check that out. That's what we have: 61, 62, 63, 64, 65, 66, 67, 68. And then if I inspect the memory there, characters at flipped, it's still zeros because we haven't written to it yet. So that's what we started here. We started the process for writing. So in X4, I'm moving the pointer to this address. So I believe it will say this. I have to step one more time, and then I believe this address should be here. Actually, I think it doesn't say the same because I think it's actually just an offset. I'm pretty sure that that came up when I did testing before. I think the actual address is not shown, and it's just some kind of offset instead that is meaningless without uh, I don't know how to say it. There's some other stuff going on in the background. So let's step. Now this would be the step where we store what's in X14, which is this, into the contents that is pointed to by X4. But it won't show yet. So now it'll show because I guess that's what's going on because this was here, I hit step, so now it should show when I hit the um, like view the memory. So there we have it. We have it backwards. So it goes H, G, F, E, D, C, B, A. And that's pretty much it. So that's how the program works. There's some nice basics for ARM64